is finding conditional probability. As it says here, slips of paper for 5 prizes numbered 1 through 5 are put into a bag. A contestant draws one number, then replaces it, and then the next contestant draws a number. So our first question here is find the probability. The first number is a 3, and the sum of the numbers is greater than 5. So what we have to figure out here is what is the probability that the first number is a 3? Well, there is 1 3 out of 5, so the probability of the first one would be a 1/5. Then it says and always means to multiply these. And then the sum of the numbers is greater than 5. Well, to do this one, we have to assume that the first number is a 3. So if how many numbers that are in that bag would give us a sum that's greater than 5? Well, if we pulled a 1, 3 plus 1 is 4, that doesn't work. If we pulled a 2, 3 plus 2 is 5, that is not greater than 5. If we pulled a 3, 3 plus 3 is 6, which is greater than 5. So a 3 works, and then a 4 works, and then obviously a 5 works also. So we would have a 3 in 5 chance of pulling a number so that the sum of those is greater than 5. Then we multiply those together. 3 divided by 25 would be our answer for that. For the next one, find the probability that the first number is odd and the product of the numbers is even. So 1 through 5, we would have 3 odds out of 5 total. And once again means multiply. And the product of the numbers is even. So we have to assume that we pulled an odd number right away. How would we make an odd number even? So if we pulled a 1, how would we make that even? Is if we multiplied it by either a 2 or a 4. Okay, same thing if it was a 3, it'd be multiplying by a 2 or a 4. Or if we did a 5, it'd be the same thing, a 2 over 2 or a 4. So the odds, or the probability of getting that product that's even would be 2 out of 5 here. So we'd multiply those together, we'd get 6 out of 25. As always, you can either leave it as a fraction, or change it to a decimal, or change it to a percent. If you leave it as a fraction, though, you have to make sure that it's simplified. Both of these are simplified, so we're good to go with those. All right. Next one, a little bit more complicated. So we have a table here, shows the number of raffle tickets sold over a 3-day festival. One ticket will be drawn for the grand prize, and we have a chart that shows the different categories on each one of the days. All right, down here we have got a couple questions here. It says find the probability, and then it says adult/Friday. All right, now how we deal with that is we got to figure out, just like any probability, we have a number on top divided by a number on the bottom. All right, and how we figured that out for this one is the number on top is putting these two things together. All right, so how many adults do we have on Friday? That would be 245. And then we would divide by all of the people on Friday. So it'd be 245 plus 86 plus 103. And then we would just divide that out. So 245 divided by all of those would give us a probability of 56.5%. All right, so how we get that again? The top number is putting both of these together, the adults on Friday, so 245, and then the bottom number is all of them on Friday. So if we come down here, it says find the probability of Sunday/child or senior. Number on top would be the Sunday children or seniors, so that would be Sunday children would be 42, plus the number of Sunday seniors would be 94. Okay, so we're going to eventually add those together, and then we're going to divide by the number of total children, so 86 plus 119 plus 42, and then also the number of seniors, so 103, 251, and 94. We would add all of those together, so the top ends up being a 136 divided by all of those numbers added together would get a total of 695. Alright, now that one, it might be simplified, I don't know. I would make sure to just change it into a percent though, so that I'm sure that I would get that right. And that ends up being a 19.6%. So once again, how we do this, when we have this weird notation here, Sunday, children and seniors go on top, and then the bottom is children and seniors. So it's always, the top is put everything together, and the bottom is just the stuff that's after this little bar here. All right, the next one, a raffle is being held at a school function. Container has the names of 587 juniors and 618 seniors who are participating on slips of paper. Prizes are being given to first, second, and third prize, or third names pulled from the container. Once a student wins a prize, his or her name is not returned to the container. What's the probability of the first two prizes go to a junior and the third prize goes to a senior? So, before we figure out the first two, we got to figure out the first one. So, we have to figure out how many total kids there are in this. So we'd add those together, and we'd get a total of 1205. So the probability of the first one goes to a junior would be, there are 587 juniors divided by the 1205 total. And then it says the probability of the first two go to juniors and means multiply. So once we win first prize, you can't win second prize, so we got to take that one out of there. So 586 divided by 1204, and then multiply that by the third prize goes to a senior. We've got 618 seniors divided by, we have 1203 total left over. So we got to multiply all those together. So we would get a huge number on top. So we're not going to worry about that. But what we would end up with for that exact situation, it would be approximately 12.2%. All right. So big part here is once you win a prize, your name is not returned to the container. So we're subtracting those out of each one of the situations that we're given here. Next one, 3 baseball caps are chosen at random and without replacement. So we're keeping them out from a box that contains these 3 colors, 6 tan, 8 gray, 9 black, and 12 blue. Find the probability that all 3 caps are gray. All right, so we got to figure out what the total is. So we're going to add those together. 14 plus 9 is 23, plus 12 is 35. So we have, what's the probability of the first one is gray? We'd have 8 out of 35. Okay, times. Now we're not putting them back, so we're down to 7 gray caps out of 34. And then 6 out of 33. We're going to multiply all those together because we want to know the probability of getting all 3 of them. So we'd get 336 on top divided by the bottom, which would give us a very small % chance of this actually happening, which would be equal to 0.85%. All right, so same thing here. Without replacement, we're not putting them back in, so we got to subtract those out of the totals for each one of those. All right, next page. It took Pleasant Puzzles 3 months to manufacture a new puzzle. In May, 976 out of 978 passed the quality control check. In June, 1031 out of 1035 passed. And in July, 984 out of 987 passed. Find the probability that a defective puzzle was made in July. All right, the hardest part about this is actually figuring out what they're asking for. All right, find the probability that a defective puzzle was made in July. Well, this question is very similar to these questions where we had this little bar in here. We're just going to figure out where each one goes. All right, find the probability that a defective puzzle, that means that's going to be part of the total, was made in July. So we want to find the probability of July, and then we've got that bar, and then defective puzzle. All right, so what would happen here is, remember, for our top, we are trying to figure out the total July defective puzzles. So that would be 3, because 984 out of the 987 passed. That means 3 of them were defective. Over all of the defective puzzles, well, there's 2 here, there's 4 here, so that's 6 total plus 3. We divide by 9, which would simplify to 33.3%. And that is it for lesson 68.